Hi everybody, welcome back. We're going to finish off 8.1 today. We are now currently on page 7. Just a quick recap of the other class. There are two solutions, are 0 and 3, negative 2 and 5 from the previous example. So it is the whole coordinate when you're solving a system of equations. Okay? And in this case there was two answers. One happened to be the x-intercept, the other happened to be the vertex. That's not always going to be the case. So I'm going to show you another way to do this, and this is using technology. I'm going to use your TID, your graphing calculator for this. So again, the easiest thing to do here, if you're solving this using technology, again, like we did here graphically, I did this one by hand, the previous example, but this one I'm actually going to use the graphing calculator to do this. So the first one you have to set equal to y. So I brought the y to the right hand side. I got x plus 1 is equal to y, or y is equal to x plus 1. Do the same thing with the quadratic. So we have a linear and a quadratic here. The second equation, again, I took everything else over and left the y here because it was already positive. Again, it doesn't matter. So I take the x squared over, get negative x squared, take the positive or minus 6x over by adding 6x to both sides, and I take the plus 3 over by subtract 3. So I got my two functions here. First one's a linear, and the second one is my quadratic. So I'm going to, this is Desmos, by the way, which is a great program, but I'm going to do it on your graphic calculator with you. So we're going to bring the graphic calculator up. Remember, when we want to clear the calculator, we do second function, mem 7, 1, 2. That RAM is cleared. So we're going to put y equals, and put the first equation, which was x plus 1. And the second, we have negative x squared plus 6x minus 3. You're going to graph the two. We have the blue is the linear, that's the first equation. Our second is the red, that is the quadratic. So to get these intersection points, it's a very simple, and I've done it with you in the past, second function calc, and we're calculating as option 5, which is intersection points. So we intersect, hit enter. So you're going to go blue curve. Obviously there's 2 points of intersection here that you can clearly see. So you want to just go up to the closest one here, hit enter. You'll notice that the cursor automatically jumped down to the second curve. You can get closer again, not that it matters, it's usually close enough. Hit enter for a third time, and you can clearly see that the intersection point is 1, 2. So coordinates 1, 2. Do the same thing again, second function calc. You're going to go down to the fifth selection, which is intersect. You can just hit 5, or you can go down to 5, hit enter, and then obviously we're going to have to go to the right. Remember, when you're going along the same curve, you just go left and right. You never go up and down. Up and down jumps from curve to curve, right? So we hit enter, enter, and enter for a third time, and the second intersection point is 5. All right. So I'll bring up my graph here. There's the two intersection points. I've graphed my linear line. I've graphed my quadratic, and you have the two coordinates using Desmos 1 and 2, 4 and 5, and I verified them at the bottom again. The verification just shows that those. I recommend verifying them with the original. That way you'll make sure that you did it correctly. So we put in 1 and 2, right? So you'll notice that x is 1, y is 2, and here the same thing, x1, y2. And then the second point was 4 and 5, and the second point was 4 and 5. So it's basically 4 verifications, 2 for each equation, 2 points. Now again, some people say this might be overkill doing both, but I just wanted to verify everything, showing that everything worked, right? So 1 minus 2 plus 1 is 2 minus 2, which is 0. 4 minus 5 is negative 1 plus 1 is 0. Same thing. So original here we got x squared minus 6x plus y plus 3. Put in points 1, 1, 2, right? 1 for, right, this one here, 1 and 2. So x is 1, y is 2. And we get 1 squared, which is 1, negative 6 times 1 is negative 6, plus 2 plus 3, 6 plus 2 plus 1 is 6, 6 minus 6 is 0, and the same thing here with the last one. Alright, so again, just some verification to make sure we're correct. I mean, the graph's not going to lie to you, but it doesn't hurt to put them back into the originals. That way you make sure that you you've at least put them in correctly, right? Okay, or you've rearranged them correctly, I guess I should say. That's it for page 7. We have one more page here for this section, and this is solving a quadratic systems graphically again. This time we have 2 quadratics. All right, and it says a system is defined by the equations, and again, I had to put them in y equals, so I took the y over here, the y over here, the negative 35 to the left, the negative 11 to the left, and I've rearranged and I've gotten these 2 functions, okay, which is important. All right, and when we do that, we solve this system using our technology. I use the Desmos program. I use the graphic calculator as well. So the Desmos, the graphic calculator, y equals, I'll clear these 2 graphs. First one I'm going to get is y equals 2x squared minus 16x plus 35. So obviously we're going to have to open that window up quite a bit. The next one's 2x squared minus 8x plus 11. Right? And then when we're going to do this, we graph. I'm going to open my window. See what happens. Now we have the intersection points. That's fine. And you notice it looks like there's only one intersection point, and you would be correct in saying there's only one intersection point actually. And the reason is, if you notice the 2x squared, if you were to set these equal to one another, let's go back to the equation. If you were to set these equal to one another, what would happen is the x squareds would actually be gone, right? Because if you have one equal to 2x squared and the other equal to 2x squared, that means they both have stretched by the same amount, and therefore they're actually going to have the exact same shape, right? They're opening up at the same amount each time, with a vertical stretch of 2. So therefore, the rest of the information, that's only translation. So that's like sliding it to the left. You know what I mean? It's not reflective. So what happens is, if we were to solve this algebraically, the 2x squared, you would subtract both sides, it would be gone, and you would be essentially left with a linear part, right? You don't have the x there. So it would be like negative 16x plus 35 equal to negative x plus 11, which would be negative 8x equal to negative 24, which would give you x equal to 3. So there's only one x value, and that's one of these scenarios. Basically, when the a value is the same, and you set them equal to one another, they're obviously going to subtract out, right? You will be left with one solution. So I'm glad this scenario came about, so you can see that. And there's the graph, and I'll go back to the TI calculator. So sometimes you have to open that window, but that's a quick way to take a look, and I showed you that before. When you have them in standard form, if the a value, the vertical stretch, or the a value is equal, the quadratic it'll only yield one solution, right? Possibly one solution, which we can clearly see here. So second function calc, intersection point, enter. First curve, we're going to have to come down a bit. Oh, you see it coming down. You see the y value going down. There we go. There's first curve, enter, second curve, enter, and third, and the intersection is 1, 3, and 5. Now again, you open up the window. They will never intersect. Again, that's because both have a 2x squared. They both have 2x squared. So if your coefficient in front of the x squared is identical, this will happen because they'll be eliminated, right? You subtract the 2x from both sides, it's gone, and you're just left with what's remaining. Okay, so a neat scenario occurring. Again, you want to confirm. So take the original, plug in 3 and 5 for y. There's 3 and 5. We end up with negative 35 is equal to negative 35. Then we can do the same thing with the second equation. We set the 3 and 5 again for x and y, and we get negative 11 is equal to negative. Just another confirmation that we're correct, and that's it. That's 8.1 in a nutshell, which is solving systems of equations graphically. I did it graphically by hand, and I did it with the graphic calculator, right? It's nice to do it by hand like I did in the first one, but again, the graphic calculator will be smooth and pretty great tool for you. So if you could do the questions in the textbook on page 435, numbers 1 through 8, on page 8, they refer to the systems of equations graph, like window algebraic in the next section, and then that's it. Chapter 8 is a quick one. All right, everybody. Thanks again. I hope you're enjoying the videos. Again, another great tool for you, and we'll see you again soon.